In nature, we can classify forces as being either conservative or non-conservative. In a conservative force, the work that's done against that force can be easily recovered. For example, imagine a diver diving into a swimming pool. They have to climb up a ladder. They're doing work against the gravitational force to go up the ladder. And then when they jump off the diving board, they recover that work in the form of kinetic energy, their motion when they're falling. A non-conservative force is one where the work cannot easily be recovered. This is the case in situations with friction or air resistance or propulsive forces. The work done against friction gets dissipated and turned into heat and sound, and you can't easily recover that. Another way of thinking about conservative versus non-conservative forces is the concept of path dependence or path independence. In a conservative force like gravity, it doesn't matter what motion you do, what path you take in the system. The work done against gravity is independent of the path. For example, let's go back to the diver jumping off a diving board. And here's the diving board, there's the pool, the water. They climb up the ladder to get to the diving board. They jump off and recover all of that work that was done against the force of gravity. But let's say that instead of diving, they go off a slide. So it looks like this, into the water. In that situation, the path taken is different. You're going down this slope, but you still have the same work done against gravity. You still end up with the same kinetic energy going off the diving board, or going off the slide, as you do landing in the water off the diving board. So this motion against gravity is independent of path. That's a characteristic of a conservative force. On the other hand, let's take a path-dependent force, a non-conservative force like friction. Let's look at a tabletop. We're looking straight down on a table. And you've got a book sitting on the table. And you slide that book around. Say you slide that book from this starting location, I'll label it point A, and you move it to this ending location, I'll call that point D. Slide the book across the table. Now there's friction on that table. And it takes less work to move the book straight from A to D than it would if you made the book take this longer path from A to B to C and then to D. You're going to do more work against the friction force by taking a different path. So friction force, which is non-conservative, means that it takes more work to go on a longer path than it does to take the shorter path. Whereas gravity, which is conservative, the work done against gravity doesn't depend on the path. No matter how you climb up the ladder, no matter how you jump off the diving board or go down the slide, the work done is the same. And whenever you have this situation of path independence and a conservative force, you can define what's called a potential energy function, which we'll do in the next video.